I know, I'm so happy, just you.
Wow.
I'm so happy. I was in 1600 crossed my name out. Yeah, need a break. Let's go.
So what do you
I'm not an anything.
Hey, get out that home. We're going to go over a couple things here. See if you got any of them right.
He's like, yeah, I need to rest you so you're not in pain forever.
How many people? Oh, I do need you to fill this out anyway, but or maybe where's it at? If you would put your name on here and list any AP tests you're taking this week or next week. And just to kind of get a feel, who's going to be out? Let me just see. Anybody out Wednesday for physics?
Oh, yeah.
Okay, 1, 2, 3, 4, 5. All right, who's out Thursday for whatever?
What's the week?
Outside. Okay. And if you don't have any, just don't need to list anything. All right, so we're gonna have to figure things out. I will not be here Friday. I know that's gonna disappoint a lot of you.
Oh.
Free day!
No.
Got a graduation party. No, graduation event in North Carolina for my daughter, so I got to go. She'll probably go to that.
Why did she say North Carolina? Oh.
That's where she goes to school.
Yeah, dude. I thought you were talking about your daughter.
Yeah, I know about you.
No, my older daughter Catherine graduates from UNC Greensboro.
You have another daughter.
I'm waiting.
Thank you, I think. So I'm going there Friday. So we got to figure out those of you who are missing. So those of you missing Thursday, I'll probably leave instructions with the Mrs. Evans, who will be 7, to try and do that. If things just don't work out, we can still do it Monday. I'm not too concerned. Either way, so we should be able to get that worked out. There's not too many people are missing. We're going to finish up 9-4 today, which is the last section, and then we will review tomorrow and Wednesday, and I'll give you that information. All right, on 24, this is the answer. I don't think a lot of you really got it. You had some answers down, but check it. If anything, you just probably made mistakes within there. Okay, so it's something I can look at individually. For that, I do want to do 81, A and B. Go over those, but look at and just see if you got 24 right. And then maybe we can figure out where you went wrong at some point later in the class. All right, 81. You do need to know how to do this. On the test, there will be a no calculator piece, which I'll let you use the red ones for computation. And there will be a calculator part where you can use all the matrix capabilities for there. But understand this, we want the directions for both of them. It says to find A. Okay, from that information. B inverse. Oh, what we got here? Jackson.
Oh. That's got the
Is exam 450? Is there any 450?
I don't know what the date's right either.
All right, who can explain how we do this and why? Popio, you want the first crack? No. Okay, you want to take an attempt here? No. No, Ian, Fauci?
I could explain to you how you can explain not explain it.
Mason?
What?
Tyson?
What are we explaining?
How to do 81A?
I multiplied AB times B of -1 because you gotta like multiply the b's together.
Okay, yes, there is a big difference between B inverse times AB and AB times B inverse. So you just can't. So he is correct because those are together. We can use that commutative property or associative property, and then that becomes the identity. And so that's going to be A. Even though we don't know what B is and we don't know what A is, we know what AB is. And so I got to multiply in this order. AB, which is -1, 3, 0, 2. The inverse is 1, 2, 3, 4. And so -1 times 1 is -1. 3 times 3 is 9. -1 plus 9 is 8. And then row 1, column 2, I get -2 plus 12. That should be 10. I get 0 plus 6. And then I get 0 plus 8. So that first one should be 8, 10, 6, 8. Okay, so for part A. Part B, they give us the fact that BA, it's the same matrix, but they tell you it's BA as opposed to AB. Well, for this one, you have to take the inverse first, because now we can regroup. And you get the identity times A, and we end up with A. So the inverse is 1, 2, 3, 4. -1, 3, 0, 2. And then, see what you get that one?
I got -1,
Okay.
7, -3, 17.
Yeah, that sounds right. All right, so double check yours. So -1, 7, -3, 7. So order matters. Okay, for this one, which one's on the left versus which one's on the right. 49, 51, and 54, you're using those matrix equations, just using the inverse. Okay, calculator, just plug it in, that's absolutely fine. All right, last section, I got guided notes here. Determinants and a little bit of Kramer's rule.
I'm pretty sure you're recording this, you never told us.
Do I need to tell you?
No, I feel like I won't say something stupid if you tell
I
us.
think I'm recording.
Okay.
It wasn't like,
It's not
I'm not trying to.
Okay, but like, if it's not, oh, Larry's class is like glass.
What do you say?
Yeah.
I can record.
I almost took a CCP,
That was my own math. Yeah, remember Charlie? Yeah, group, me, you,
With no feet. What are you looking at? Yeah, it's not a fucking. I was thinking of jabbing the arm. I was thinking, oh, this is.
Sarah, you gonna beat Sophia this week or later?
Yeah.
Or is it Kim? I don't know.
She's, I got that's right.
Yeah, she was a freaking guy freshman year. Yeah.
What? I really don't know how to.
Not this weekend, Jackson on Tuesday.
No,
We'll see, we're resting a lot.
Yeah, well, Nathan's running down Nathan and Alex are running down at Mason on Friday, which makes things complicated for AP tests because they got to leave school.
What do you mean, what are they doing?
They're running the Mason mile down by Cincinnati. Yeah, go back. That's what Vinny Marty ran for. No, Justin Gordon ran 403. 3 years ago. So it's a fast meet. The winning time is usually something like that. So I was thinking racing Nathan or Alex.
I don't know.
It's racing 8 o'clock Friday night. So I'll just put on a mouse with one. Nathan won't be like a mouse with that.
All right, listen up. We're going to talk about determinant, and then that's going to lead into what's called Kramer's rule, just another way to solve the systems. Determinant. 2 by 2 is pretty easy to figure out. Once you get to 3 by 3, it gets a little more complicated. But here's the case. When you see this symbol, it looks like absolute value bars. That means determinant. That does not mean absolute value of a matrix. It means determinant. Notice the difference. If they're just talking about a matrix, you'll have brackets. If you just have bars, it'll be determinant. On your calculator, we'll go over this. You hit second matrix. Under math, it'll say DET. That just means determinant. We'll need your calculators here in a little bit. All kind of other operations, but the main one we're going to use is determinant there for that. If you take a look, determinant of a 2 by 2, AD minus BC. That's all you got to do. It's a constant, it's not another matrix. So write that first one down there. The way it is written, those bars are telling you to take the determinant. And we just need to multiply -6 times -3. Okay, minus 5 times 4. And that gives me, what does that give me? 18 minus 20? -2. So the determinant can be a negative number. Now, if it's a 2 by 2, it's probably going to be easier to just do it by hand. To do it on your calculator, I'll just do it real quick. I'll enter 2 by 2, -6, 5. Is that +4?
Yes.
+4 and -3. The biggest issue with any of this stuff in your calculator, if you just input something wrong, you end up with the wrong value, and you really don't know why, and you don't recognize it till later on, if at all. You have to quit. You have to go to matrix. You have to go to math. You have to hit enter, and then matrix. Under names, determinant of A, -2. So we'll calculate it, but for 2 by 2, it's probably easier to do it by hand. All right, go ahead and figure out the determinant of that 2 by 2 there for number 2. And Lizzie, what are you getting?
Zero.
0. All right, everybody sign the AP testing paper.
What a disappointment.
All right, 36 minus 36 equals 0. Okay, I agree. Kramer's rule. It's going to be very similar for 2 by 2 and 3 by 3. It involves matrices and determinants. X equals what we call d sub x divided by d. D is the determinant of the coefficients. You take the coefficients of x and y, put those in a matrix, find the determinant. D sub x, you take out the coefficients of x, you put in the constants for that right there. And d sub y, you take out the coefficients of y and you put in the constants there. So for this, go ahead and copy down that first one, or it's already down there for you. May 5th physics. May 5th physics. May 7th. All right. If it's got to be in order. X, Y equals constant. It's got to be like that. Our D value, which is the determinant, is just going to be 5, 4, 2, 3. D sub x. Take out the x values, the 5 and the 2, put in 1 and 6. And then you got 4, 3 here. And then d sub y equals, keep the x coefficients, take out the y's and put in 1, 6 there. All right, follow your rules, find d sub x, d sub y. Just do AD minus BC. All right, so for D, I get 5 times 3. I get 15 minus 8. I get D equals 7. D sub X. 3 minus 24. I get D sub X equals negative 21. And then D sub Y. 5 times 6 is 30. Minus 2 times 1 is 2. D sub Y equals 28. All right, now don't forget the answers here. X is D sub X divided by D, which will be negative 21 over 7. So I get negative 3. And then Y is D sub Y divided by D, which is 28 divided by 7. So you get 4. All right, so in the end, ordered pair negative 3, 4. Now, just using determinants, we can come up with X and Y. All right, do this. Go ahead and do this one on your own. You should get whole numbers. If you get a fraction, decimal, stop. But 4x plus y equals 146, and then 9x plus y equals 66. I don't want to.
I'm down.
You're dead?
Connor, Dad. Connor's dead. All right, do that one.
Hi, Jackson, since you're leaving us early, you can help out. 4, 1, 9, 1. Do you have the determinant for D? Negative 5. So 4 minus 9 is negative 5. All right, agree. D sub X, it's going to be 146 here, 66, 1, and 1. What'd you get for that? 80? Okay. And D sub Y, I'm going to have 4 and 9, 146 and 66 here. And what'd you get for that? Negative 1,050. All right, so our X value is D sub X divided by D. 80 divided by negative 5. Is that negative 16, Jackson?
Yeah.
Oh, thank you there. What'd you get for the Y value? 210? All right, so good. So Y equals D sub Y divided by D. So 1,050, or is it negative 150? Negative 150, sorry. Divided by negative 5, so Y equals 210. So negative 16, 210. Are we good there?
Yep.
Find the determinants using that. All right, that leads us to 3 by 3. Now, 3 by 3, there's 2 ways to find the determinants. One's a little bit complicated. We're not going to go through that. We're just going to do the easier one, actually. The one thing about this more complicated way, it works for 4 by 4s and 5 by 5s, but we're not really going to cover those. So we're just going to skip this. It's there for your reading if you want it. But go ahead and flip it over on the back. And you already have that one written down? All right, kind of the cheap way to do this, and this is probably the way you did it last year. If we did this, I can't remember based upon when you guys went online. You got a 3x3. Take the first two columns and recopy them right next to it. Okay. Now we are going to multiply starting the top left corner down the diagonals. And we're going to multiply and add those all together. So underneath here, you're going to multiply 3 times 4 times 1, which gives us 12, plus 4 times 3 times 4, which is 48, plus 1 times 1 times 3, which is 3. Now we are going to subtract. Okay? Hold on. And we are going to, from the top right, go down the other 3 diagonals. Now we're going to add those together, but in the end, we're going to subtract that sum. So I'm going to subtract 4 times 1 times 1, which is 4, plus 3 times 3 times 3, which is 27, plus 16. All right, add the left, or add the first parentheses, add the second parentheses, subtract. And so we get 12 plus 48 is 60. 63 minus 47. Looks like we get 16. All right, just make sure you can enter this in your calculator. Take your original, go to your matrix, go to edit, and plug in that matrix. And then just hit determine. And you just visualize.
Great numbers.
Three, 4, 1, 1, 4, 3, 4, 3, 1. Okay, second quit. Matrix, go over to math, determinant. Yeah, tell it what you're taking the determinant of. Matrix A, 16. So make sure you get that. One thing you got to watch, though, is we deal with some matrices that have variables in them. If it has any variables in it, then you just can't type it in your calculator. So you do have to know the procedure. All right, so copy this one down there. And then re-copy the first 2 columns, and then we're going to go along the diagonals. So from left to right, I get 0. Now I got a z and x and a y. I'm just going to call that x, y, z. Plus x, y, z. Plus I got another y, z, x, and we'll call that again x, y, z. Minus. Going the other direction. I get, the one thing is you're going to notice that zeros are nice. Because z times 0 is going to be 0. 0 times x is going to be 0. And y times 0 times y is going to be 0. So basically, if you got a 0 in a diagonal, the whole thing is 0. All right, what are we left with there? We're really just left with xyz plus xyz, which we can write as 2xyz. Okay, for that. All right, so determine the same way. Just be careful with your variables. This leads to Kramer's rule. 3x3, it's exactly the same as a 2x2. Add an extra column. X is d sub x divided by d, y is d sub y divided by d, and z is d sub z divided by d. Well, and so the only thing you do is d is all the coefficients, d sub x, take out your x, replace it with the constants. Same thing for y and z. All right, write this down if you would on the bottom. All right, now the one thing you gotta watch, and I gotta put the situation here, is you gotta have everything in order. Things are mixed up, you gotta reorganize them. Otherwise, your matrices and determinants will be off. So I'm just gonna make this 7x plus y plus z equals 1. 5x minus 2y plus 3z equals 4. 4x plus 3y minus z equals 0. So let's take a look here. So d equals 7, 1, 1, 5, negative 2, 3, 4, 3, negative 1. Okay. D sub x is going to equal, all right, take out your x coefficients, that whole column. The 7, 5, 4 go out, and we're going to put in 1, 4, 0. So I'm going to put in 1, 4, 0, 1, negative 2, 3, 1, 3, negative 1. D sub y, same idea. Take out from your original D, take out your y column. So everything else will be the same. So I'm going to have 7, 5, 4. Okay, my y column comes out. I put in 1, 4, 0. And then I still have 1, 3, negative 1. And then D sub z, replace the z's. So 7, 5, 4, 1, negative 2, 3. And then the last column will be 1, 4, 0. You definitely may use your calculator and just type it in. I suggest you split it up. One of you do 2 of them, the other one of you do 2 of them. So save a little bit of time.
I'll do the last two.
I'll
do Y and Z. Matrix.
Hey guys. Hey, what? You guys,
What if you wanna do X and Y, I'll do Z.
I can do it.
what is I'll do D.
Now everything should be a whole number. Even your X, Y, and Z when you're done.
What's D?
Yeah, next
I got D.
Matrix. Negative 27. Which one's that one?
What is X or Y, guys?
So this is what you get.
I'm gonna do matrix.
You go for it. Trusting it.
Z is negative 45.
D is negative.
Well, these are chunky. 27.
Kate, what you got back there?
B is negative 9.
Okay, what else you got?
E of X is 9.
Okay, Ian, you got the other two? All right, so those sound right. Now, don't forget, you gotta figure out what X, Y, and Z are. So X is D sub X divided by D, which is 9 divided by -9. So it looks like we get -1. Y, D sub Y divided by D, which is -27 divided by -9. So Y is 3. And then what do we get for the last one? 5. D sub Z divided by D, -45 divided by -9. So I get 5. So it looks like in the end I get -1, 3, 5. So that's Kramer's rule with 2x2s and 3x3s. For 50 and 58, when you're finding a 3x3, you are definitely allowed to use your calculator and just type it in. Okay. If it has a variable in it, then obviously your calculator won't work. You got to know how to do the other method. So you do have a little bit of time here. See what you can get done.